worked really hard on this playlist. I don't want others like me to feel lost in Logisim Evolution. The teacher gives you instructions to do this, do that. But unless you already know how digital circuits work, you cannot follow along. The pressure mounts up like it did for me. I had to withdraw from the course. Now, working at my own pace, I realize it was never as difficult as it felt. If you follow along till the end of this playlist, you will have enough confidence to attempt projects in Logisim that you never thought were possible. This pentagon shaped thing is an input pin. These pins take in data, in this case, the values of matrix A and matrix B. To draw a wire, hover your cursor over the small pin section of the input pin at the top. Pay attention to which cursor I am using. The black arrow cursor, not the finger one. The finger cursor comes later. I am copying these two input pins using Ctrl plus C, pasting with Ctrl plus V, then dragging the duplicate. When you hover over the duplicate to move it, your cursor should look like a compass. If it does not look like that, either it will not move or you will end up with something like this. I will explain why I am copying so many times in a moment. There was a simpler way to do this for a 2 by 2 multiplier, but I want to show you how data actually flows. So I am breaking the processor into separate parts. Start naming your input pins. This is crucial. A wrong name breaks the circuit or breaks your logic. Rules: the name must start with a letter. It cannot be the same as a built-in component name. Logisim will tell you the rest if you break a rule. Read what it says, it is helpful. Everyone who clicked this video probably has some idea of matrix multiplication. But if you do not, no problem. Here I have drawn two 2 by 2 matrices on the screen. 2 by 2 matrix means 2 rows and 2 columns. Matrix multiplication is only possible when the number of columns in the first matrix equals the number of rows in the second. That shared number determines whether two matrices can be multiplied. As you can see, each row of matrix A multiplies with both columns of matrix B. Go to the arithmetic section in the left panel, scroll down slightly, expand it, select multiplier, single click only. Bring your cursor back to the canvas. A square shape follows your cursor. Place it at the end of your wires. The wire turns orange. There is an error. Read the bottom of the canvas. Incompatible with. Two pins have mismatched bit sizes. The multiplier defaults to 8 bits. The input pin is still at 1 bit. Click on the input pin. Under properties at the lower left corner, uh, you will see data bits. Change it to 16 bits. Now a common question arises: why 16 and not 8? An 8 bit second mind in this current video, I'm using an 8 bits set. Since this was shot before I knew that I would have to use a 16 bit. The input pin gets 8 green dots, 1 per bit. Also change the radix from binary to unsigned decimal or hex. Unsigned decimal just means whole positive numbers, no decimals, no negative, and you will see the error disappears. So R1 is equal to A multiplied by E plus B multiplied by G, as you can see on the screen. Two multipliers, one adder connecting their outputs. Let me quickly do the same for the other input pins. Connect the adder to the multiplier outputs. Wait, I need to fix something. I apologize, I am a design freak. I cannot work with messy schemes. Let me fast forward while I clean this up. Last step, the most important one, output pins. Do not skip this. If you leave the wire hanging without an input pin, when you use this core in the main circuit, you get this and data bits to match everything else in the circuit. And that is the complete code for 2x2 matrix multiplier. I know some of you will say in the comments there was a simpler way to build this. You are right. But to understand data flow as a beginner, some hard work now means smart work later.